welcome to episode 2 of Multivariable Physics. This episode is going to be on graphing functions, and we're going to be talking about graphing scalar and vector functions. So if you don't know what those are, or you're still a bit fuzzy, go back to those, to the last video, and then you can ask questions and things like that, and maybe I'll answer. But in this case, we're going to actually think about what does it mean to graph these things. So we're going to begin with vector valued function, or not vector, sorry, scalar valued functions. So what exactly is this gonna show up? So let's just think about what does it mean to graph a regular function. Okay, so we're gonna x, and then our y-axis f of x. Okay. Well, let's just think of this function f of x, okay, equals x squared. So this is 0. We're not gonna worry about minus x, okay? We're not gonna worry about minus x for now. So what can we think about? So we'll start, well, f of 0, well, this is gonna be equal to 0. F of 1 is equal to 1. F of 2 equal to 4. You know, we can plot these points. So there's 1, there's 2, here's 1, here's 2, here's 3, here's 4, right? So we can plot these points. And so we start, get into the color here. There's a first point, right? And then orange will be a next one. And then we'll have this blue be our second. So the second point's gonna go somewhere here. This orange point's gonna go somewhere here. And I know this looks linear, it's because I'm bad at drawing this, but as we go along and we fill more and more pieces, right? We fill more and more chunks in here. You're gonna find that we get a piece here, 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 right? You're gonna end up drawing this, you know, this curve that's gonna keep going up and up and up and up and up, right? So we just fill all of these pieces. This same intuition, we can use the same intuition for graphing multivariable functions. It's just we have a second variable to consider. So let's think of this function. I'm going to graph the function. So here's our x. And then let me make that just a tad bit straighter. Right? F of x, y. And then I'm obviously going to, here's our origin, that's 0. I'm only going to focus on f of x. Let's make it a bit more centered. F of x, y is equal to x squared plus y squared. Okay, so what does this look like? Well, we can do the same thing. So we know at x, you know, we have our regular parabola. This is when x is equal to, so this line, this red line, this is f of x and 0, right? That's just f of x squared. This orange line, well, we can, if you hold 0, or x is 0, then we just have y squared. So you get, you know, we get this in this direction. I hope it should be clear that this is, you know, down this x-axis, and this is down this y-axis here, okay? And this obviously continues for the negative values, but I won't do that. And then, so in the middle, okay, in these middle points, well, we can just kind of do the same thing. From x, we can hold x squared plus 0, x squared. So we have x squared, f of x, 1, f of x, 2, etc. And we can fill those in. We have this x squared, and we put in, you know, f of x 1 when y is 1. It's going to be the same graph, but it's just going to be translated 1 into y. So it's going to look like this, you know. It's going to go down, and it's going to go, here's y equals 1, right? And then we can keep going for all of these points. And then what's going to come out is we're going to get some, I'm going to draw it in blue here. We're going to get this surface that covers all of this. You get some weird surface, and I'll show some graphics for that later, but right. And that's only considering this. If we actually consider the whole thing, this is going to form like some what's called a paraboloid around f of x, y, right? So this forms a flat surface. So I hope that makes sense. Then the next thing we want to think about is, well, what about vector value functions? And it's pretty much the same process, except at every point we don't have a single point. Instead, we have an arrow. Okay, so a vector value function is going to be like this. So this is scalar. Let's look at the function f of x and y. In this case, we actually don't need to use 3 dimensions. You can just use x and y. Okay. And then we start obviously at 0. Nothing happens at 0 for this thing. We'll think about equals x cosine y, x sine y. Is that right? Or actually, wait, I might change this up. Just something simple, x, yeah, x plus y, and then here x minus y, I don't know. Something like that. We'll just think about this. When they're both 0, obviously this is the 0 vector. We don't have to think about anything. But what if you have 1 and y is 1? Well, let's just think about this. F of 1 and 1 is equal to 2 and 0. Okay. What does this mean? Well, this is a vector that has, this is a vector pointing here with magnitude 2. Right? So at this point, I have a vector pointing this way, the length of 2. What about, and then obviously we know that at every point we have 0, y. This is all only points in the y direction, right? And then what about the point f of 1 and 2? Well, this is going to be 3. And then, well, 1 minus 2 is minus 1. So that's going to give us 1, and then here's 2, 1. All right. At this point, well, we have a vector that goes 3 to the right and 1 down. It's going to look like this, right? And it has magnitude, 4. Wait, no, it has magnitude 9 plus 1. It's rooted, which is square root of 10, right? So that's it. So this has length square root of 10. And for every point, we can continue doing this. We have all these arrows and things like that, just pointing. And that's what this vector function is going to look like when it's graphed, okay? So hopefully we got into how to graph these, and then hopefully that makes sense. Next up, we're going to go into actually taking derivatives and how we can do calculus on these.